All right, guys. You are so very much welcome to this channel. Now, in today's video, remember we are continuing from the last two videos, I think so. One, we will look at the first one. We were looking at how a program executes, what happens, how the operating system helps us through system calls. And now the second video was about RAM, how it's organized, what goes where, what data goes where when our program is executing. And now today we are going to be looking at the registers. Remember, the registers are also a component, a major component during the execution of our code. And as you can see in this assembly file, the same assembly file I'm using for consistency, this, as you understand, these sections, the data, the text, the BSS, these are memory segments, and this data we are initializing the data segment, the uninitialized data in the BSS segment, and our code goes in the text segment. Now if you look at the CPU instructions, we are moving one. By the way, this is the source, this is the destination, source, destination, source, destination. And we are moving one into RAX, we are moving one into RBX, we are moving the variable into RSI. Now RAX, RBX, RSI, RDX are the CPU registers, and basically CPU registers, that is temporary storage or working location built into the CPU. Like if the CPU is going to execute anything you wrote and that something is in the RAM, basically it first moves that object from the RAM into the registers. The registers are temporary memory locations, and as we can look at this table here, basically these are we have three kinds, I think, major types of registers. We have the general purpose. These are the general purpose registers in this table. These are the general purpose registers. We have the flag registers down here, and we have the XMM registers. Now, first, in the general purpose registers for 64-bit systems, the registers are 64-bit. As you can see here, we have the RAX register, the RBX, RCX, RDX, RSI, until R15. That is, we have R8, R9, R10, up to R15. Now, when you go into the RAX register, it is 64-bit. 60 by a bit is a 1, always remember. Our code runs in zeros and ones. That's the machine. That's what the CPU understands. Now, the lowest 32 bits of this RAX register is the EAX register. I don't know if you understand me. Just assume this register to be a block of 64 bits. Part of the 32 bits, the lowest ones, is the EX register. We can reference it as the EAX. The same for EBX until R15D. Now here it becomes R15D. And the lowest 16 bits still is AX. BX here from 8 to 15 becomes R8W, R15W. That stands for a word, I think, because a word is 16 bits. When you go to the lowest 8 bits, this is its representation. That's ALs, BLs, CL, DL. From R8 to R15, we use B, stands for a byte. Now, Remember, we have said we are assuming this is our memory, right? This is our memory, right? And that's our RAM. And we have initialized a variable hello world as a double word. This DW means a double word. Now, when we start the code in the text segment and we tell the CPU won't do anything when something is in the RAM. It has to first get it from the RAM to the registers. Now that's where you see here it is moving our variable to the RSI register, because this is 64-bit, and again it's moving the length of our variable to the RDX. Understand? Now basically those are the registers, the general purpose registers. These are mainly used in this CPU instructions. Now before we can go to anything, sorry for that, I'm going to explain. There are some special registers I need to explain: the RSI, the RDI, the RBP, and the RSP. Now the RSP, I'm going to start with the RSP. The RSP, this one is used point to the top of the stack. As you all know, the stack is where functions store their variables that they are running, and basically this RSP register is the stack pointer register, and it points to the top of the stack. Remember, we can push or pop things to the register. Those which I recommend you go and watch those videos. Before I go on, don't forget to like, comment, subscribe, and you can tell me of what kind of videos I can make and so on concerning programming, I think in the future videos we shall be programming. We shall talk about that anyway next time. Now the RSP it points to the top of the stack, right? If you want to pop something out of the stack, you're going to pop something that is at the top of the stack. Understand? So next is the RBP. This is the base pointer. This is the base pointer register, and it is a base pointer function calls, and it should not be used for any data or any data usages. It's just the base pointer during function calls. This is the base pointer register. Now next is the RDI, I think. RDI. So you start with the R. I forgot one, I think so. I forgot one very important register. I think I'm going to fix it somewhere here. I forgot this is, I think, the most important register. The RIP. This is the instruction pointer register. Now, the reason why we call it the instruction pointer register is because it points to the most current. Is it? It points to the next instruction to be executed. Now, as you can see here, we have 4 instructions: move 1 to RX, move 1 to RBX, move 1 to RSI. Now, if the CPU is at this line, at this instruction, the RIP is going to point to the next instruction, which is this. Understand? At any point the CPU is executing a given instruction. Now, to know its next instruction, it looks into the RIP, that is the instruction pointer register. Understand? I think the RSP, RBP, RIP, those are kind of the most important flags. Yeah, I can say that. Yeah, probably, yeah. These other ones I use the normal data. In normal data, for example, the RIX is where we expect normally is where we put out the system call numbers as we are writing assembly code. Now the flag registers. The flag registers, they are also important flags in such a way they store. They are used for the status and CPU information. Just assume you are going to write a while loop, and that while loop, for example, is going to be saying, our while loop, for example, let me just type here. This is not a code. Let me just type here. Let me say we're going to say while x is less than 7. Just this. This is not assembly code. It's just normal while loop. Can be Python also. Now, when the CPU is to execute such loops, it uses its instructions. That's loop, jump. That is the CPU instructions for such things can be JE, that is jump if equal, JZ jump if 0, jump, that's a normal jump, and so on and so forth. These are the instructions the CPU understands. Now these are what we model, and I think loop, yeah, loop. These are the instructions we use to model such advanced languages. For example, in Python, this no, I'll stick. Now, for example, if you have a while loop, and at the end of course your while loop, you are decrementing x. Now the loop will run until the 0 flag is set in the ZF register. I don't really understand that. The loop will run until the 0 flag is set to 0 in the ZF register. Now that's why they save the status. The 0 flag, the carry flag, parity, are just sign flag. You understand? We shall go into that later in programming. The last kind of flags are the XMM registers. Now these wrote some whole bit of code here. They are dedicated registers used to support 64-bit and 32-bit floating point operations and single instruction multiple data. Single instruction multiple data, that's a mouthful. Now what that means is you have like a single instruction, but it's working on multiple, on a large, not large speed, okay, whatever. It's not working on a single data set or whatever. It's working on multiple data, single instruction, multiple data. Those are the XM registers, and they vary from XM0 to XM15. And I think those are the flags. What you should note is they are temporary storage. The CPU uses them. It gets things from the ROM first to the registers and then to process it. Yeah, I think I should stop there. I'm sorry, guys. We're about to get into the programming, the real deal. That's yeah. We shall talk about programming. I'm going to make a video of the programming. How we're going to start about, how we're going to, what languages, how to start for those ones who don't know still where to start from, those who started but they don't know what to do with the languages. Yeah. Hey, thank you for watching. Don't forget to like, comment, and subscribe. All right. Thank you, guys.